Now that you know Aircuity is uniquely designed to deliver energy and carbon savings while enhancing IAQ through its patented platform, we will show you how Aircuity works within a typical laboratory arrangement, integrating with other lab controls for fume hoods, temperature, and pressure regulation. A laboratory will typically have a supply and general exhaust valve that modulates the airflow in response to three airflow drivers: temperature, hood demand, and air quality. The fume hood is where experiments, chemical mixing, and permitted quantities of chemicals can be stored. To maintain containment, a typical 6-foot hood would require between 350 to 1200 CFM. Snorkels and other capture devices also require airflow, and all such devices create a minimum flow which must be met via the supply air. The BMS or lab control system and temperature sensor are dedicated to controlling thermal comfort. Aircuity is sensing in the general exhaust for any air quality events that occur in the room, not in the hood. The BMS or lab control system is going to then high select, meaning it will provide enough to meet the highest flow demand, whether that is the temperature, fume hoods, or Aircuity. Here's an example situation. Assume both the fume hood and temperature are satisfied and the ACH is at the day set point of 4. If a container is left open on a benchtop causing a TVOC event, Aircuity would send a proportional command to the lab control system to raise airflow, providing increasing air change rate up to 16, so 4 times as much. EH&S can then go to myaircuity.com and see which sensor triggered the event, the magnitude of the measurement, the corresponding reaction of the room's ventilation, and when the room is back to an acceptable condition. Minimum air change rates are always applied based on ASHRAE assigned risk levels. Aircuity can be applied in the majority of laboratories, but savings will be restricted in certain labs based on ASHRAE hazard level assignments. In some more hazardous rooms, Aircuity may only be installed to monitor instead of actively controlling to a higher ACH. In conclusion, each room is controlling airflow to address the condition most in need, always optimizing safety, comfort, and energy use. Aircuity, optimizing airflow for healthy and sustainable labs.